So for 7.6, we're going to learn how to solve exponential equations. And we learned in the last section that exponential equations are any function or equation that has x as an exponent or has a variable for an exponent. So the first part says write the following numbers as exponentials with a base of 3. So essentially on numbers 1 through 5, we want to rewrite them as 3 to some power, 3 to the x. So you have to think about what exponent is going to get me to that answer. So for 81, if I want to go from 3 to 81, I have to raise it to the 4th power. So I'm going to rewrite this as 3 to the 4th. So 3 to the 4th equals 81. The next one is already at a base of 3, so I could just rewrite this as 3 to the 1st power. For number 3, I have to think 3 to what exponent is going to get me to 1/3. So something needs to go here in order to get me to 1/3. Well, since the 3 is on the denominator, that means that it's going to be a negative exponent. And then also this is just a 3, so it's just raised to the 1st power. So the negative exponent means it's going to the denominator, and then the 3 staying the same just means it's raised to the 1st power. 4 is a little different because I now have a negative exponent, so I know that it's going to be a negative exponent. But then I also need to think 3 to what power gets me 27. So 3 cubed. So the negative just means that it is on the denominator, and the 27 is what the 3 is for. So negative 3 would mean 3 cubed and then on the denominator. The next one, I have the square root of 3. So 3 to some power is going to give me the square root of 3. Well, I can just rewrite that as 3 to the 1/2. So all of these have the same base. They all share a 3. And that's what it means by base, just whatever is at the bottom, and then the exponent would be the exponential. So for the property of equality, or how I'm going to solve these, is that if I have two things that have the same base, two sides of the equal sign that share the same base, then I can set their exponents equal to each other. So if I have same base, then I set exponents equal to each other. So if I look at number 1, 4 to the x is equal to 4 squared. So the bases are already the same. They both are 4. So I can set x equal to 2. So I'm setting the exponents equal to each other. So that one was an easy example. But we'll have to learn how, or we'll have to know how to change the bases. So here we have 2 to the x is equal to 4 to the 6th power. Whenever you're solving, it is easiest, or it is best, to go to change the base of the larger number. I'm going to erase that because it covers it up. So I'm going to write out to the side, change base of larger number. And the reason why is if you try to go from the smallest number to a larger number, you end up having to use a fraction as an exponent. So I'm going to rewrite this as 2 to the x equals 2 squared to the 6th power. So all I did is I changed this 4 to a 2 squared. And they both equal the same thing. So the stuff that's in the parentheses, if you were to work that back out, you would want it to equal your 4 again. So 2 squared is 4. But now my bases are equal. The next thing that I want to do is I actually want to solve out. So I'm going to rewrite this as 2 to the x equals. Then I need to combine these exponents right here. So I have a power to a power, so I would multiply them. So 2 times 6 is 12. So my final answer, I can now set these exponents equal to each other to say that x equals 12. And that would be my final answer. Okay, the next example, we have 4 to the x equals 1/2 2x minus 3. So remember that you are going from large to small. So I want my bases to both be 1/2. So 1/2 to some power to the x equals 1/2 to x minus 3. So I need to think about what exponent, when I raise 1/2 to an exponent, is going to get me to 4. Well, I know that it needs to be a negative. The reason why it needs to be a negative exponent is because I need to bring this 2 back to the top. So if it were a -1, then that would bring me to be a 2. And then to get from 2 to 4, I'm going to have to square it. So 1/2 to the -2 is going to get me back up to 4. So everything that is inside this parenthesis right here, if I were to work this back out, equals 4. So if I were to work this back out, then it would be 4. But I leave it because now I have two bases that are the same. They are both 1/2. So now since they are both 1/2, I can set this -2x equal to 2x minus 3. So I'm going to rewrite this out to the side because I didn't multiply. So I'm going to rewrite this as 1/2 to the -2x equals 1/2 to the 2x minus 3. Now I set my exponents equal to each other. So -2x equals 2x minus 3. Now I'm going to solve for x. So I'm going to subtract 2x on each side. -4x equals -3. Divide by -4. So x equals 3/4. And that would be my final answer. If you want to check your answer, you can plug 3/4 back into x using your calculator, and you should end up with the same answer on both sides. Okay, the next one we have 25 to the x and then the square root of 5 to the 6 minus 2x. So I'm going to rewrite this, and this is just what I like to do, is I rewrite this, I go ahead and rewrite this as 5 to the 1/2 of 6 minus 2x, and I keep this as 25 to the x, just at first, because I don't like dealing with the radicals, so I'm going to go ahead and get rid of that. Then I have an exponent, or a power to a power, so 25 to the x equals 1/2 to the 6 minus 2x. I'm going to multiply these. So 5 to the 3 minus x. So what I did is I multiplied the 1/2 by 6 and by the 2x. Now I want to take this 25 because I go from the bigger number to the smaller. and I want to turn this into 5 squared to the x equals 5 to the 3 minus x. Then I multiply my exponents power to a power. So 5 to the 2x equals 5 to the 3 minus x. Now they have the same bases, so I set my exponents equal to each other. And I can say that 2x equals 3 minus x. Add x to each side. 3x equals 3, so x equals 1. Next example, 9 to the 2x equals 27 to the x minus 1. Go from larger number to smaller number, so I want both of my bases to be 9. The only thing is I cannot take 27 to the base of 9. So a base that they both have in common, I might have to change both of them. They both have a base of 3 in common. So I could rewrite 9 as 3 squared to the 2x. And I could write 27 as 3 cubed to the x minus 1. And so the reason why I changed both, so sometimes you have to change both to a base they have in common. And the reason why is because if I were to just take 27 to the 9th, then I'd have to cube root it, and then I'd also have to square it. So you could say that it's 27 to the 2/3, but then you're dealing with fractions, and that gets kind of messy. So you can do it either way, but I like to change them both. So then I'm going to rewrite by multiplying my exponents, these two. So 3 to the 2 times 2x is 4x equals 3 to the 3x minus 3. Then I set my exponents equal to each other. So I have 4x equals 3x minus 3. Subtract the 3x. So x equals a negative 3. The next one, I have 100 and 1,000. They both share a base of 10. So I could rewrite 100 as 10 squared, and I could write 1,000 as 10 cubed. Then I'm going to record my exponents, so 7x plus 1, 3x minus 2. Then I need to distribute my bases. So I'm going to rewrite this as 10 to the 14x plus 2 equals 10 to the 9x minus 6. Then I set my bases equal to each other. 14x plus 2 equals 9x minus 6. And I solve for x. Subtract the 2. 5x equals negative 8. So x equals negative 8 over 5. The next one, I have 81 and then 1/3. So I'm going to change both of these to be a base of 3. So I'm going to take this, and if I were to change this to base of 3, it would be 3 to the 4th power. If I were to change this to be the base of 3, it would be 3 to the negative 1. Now I'm going to put this in parentheses to the 3 minus x to the 5x minus 6. Now I multiply. They both have the same base, so I multiply my exponents. So 3 to the 12 minus 4x equals 3 to the negative 5x plus 6. I set my exponents equal to each other. So 12 minus 4x equals negative 5x plus 6. Add 5x. So 12 plus x equals 6. Subtract 12. X equals negative 6. The next one, what do an 8 and a 32 share in common? They both have a base of 2. Sometimes it takes a little bit of thinking, just trial and error maybe on your calculator. If you don't have a calculator, think about bases. I'm not going to use really big bases, maybe like 2 or 3 or 4, but nothing too difficult. So I'm going to change this 8. I'm going to rewrite that as 2 to the 3rd. And I'm going to rewrite this 32 as 2 to the 5th power. So 8 becomes 2 to the 3rd. 32 becomes 2 to the 5th. Then I'm going to rewrite my exponents. Then I need to multiply. So 2 to the 3x minus 3 equals 2 to the 15x minus 10. I set my exponents equal to each other. So 3x minus 3 equals 15x minus 10. Then I solve for x. So subtract 15x. Add 3, divide by negative 12, and I get 7 over 12. The next one, I'm looking for a common base that they both share. I'm going to use 5. So 5 squared gives me 25. And then 5 to the negative, remember there's a negative exponent because it's on the bottom, and then cubed, so 5 to the negative 3 would get me 1 over 125. Then I'm going to copy down my exponents, so 10x plus 8, 4 minus 2x. Then I multiply, power to a power, multiply. So 5 to the 20x plus 16 equals 5 to the negative 12 plus 6x. Then I set my exponents equal to each other. So 20x plus 16 equals negative 12 plus 6x. Subtract 6x, subtract the 16, so I end up getting 14x equals negative 28. Divide by 14, x equals negative 2. Here we have 9 and then the square root of 3. I'm going to make a base of 3. So I could rewrite this as 3 squared. And this is 3 to the 1/2. Then I copy down my exponents. So 2x, 4 minus x. I distribute, or I multiply my exponents. So 3 to the 4x equals 3 to the 2, so 1/2 times 4, minus 1/2 x. Then I set my exponents equal to each other. So 4x equals 2 minus 1/2 x. I'm going to add the 1/2 x to each side. Get a common denominator. So 8 over 2x plus 1/2 x equals 2. Then I'm going to multiply by the reciprocal. 2 over 9, 2 over 9. So x equals 4/9. Okay, the next one, you want to get everything to one side. You want to isolate your radical term. And so when you're trying to solve for x, I think some people have been struggling with this, especially on the quiz. When you're solving for x, think about doing PEMDAS backwards. I know that sounds funny, but you want to add or subtract first. So here I'm going to subtract 1 from each side. And so I end up with -5, 2 to the 3x equals 3/8 minus 1, or I'm going to rewrite this as 8/8. So 3 minus 8 gives me a -5/8. Then I'm going to divide by -5. So that's where the multiply divide comes in. Divide by -5. 2 to the 3x equals, then -5 divided by -5, I end up getting 1/8. And it's kind of like multiplying it by 1/5. The 5's cancel out, or -5. The negatives cancel out. That's how I get 1/8. Now, this is where I change my base. So I have a base of 2. I'm going to keep that as a 2. I'm going to change this 1/8. So I can keep this as, I can either go from 2 to 1/8, or I can go from 1/8 to 2. I may want to go from 1/8 to 2, because then I would have a fraction as an exponent. So I'm going to change this 2 to be 1/8. If it's going to be a negative exponent, then when I move it to the bottom, so then 2 cubed is what gets me the 8. So it's a negative exponent, bring it to the bottom, then it's cubed, so that's why I have a 3 there. Equals 1/8. Then I'm going to copy down my exponents. So here I have 3x. This is an imaginary 1 right here. So I have just to the first power. So now I'm going to multiply these, and I have 1/8 to the -9x equals 1/8 to the first. Then I set my bases, or I set my exponents equal to each other. So I can say that -9x equals 1. So x equals a -1/9. Okay, last example. I want to get rid of this 4/3 first. So I'm going to multiply each side by 3/4. So that goes away. Then I'm going to rewrite this as, oops, not x. I'm going to rewrite this as 11 4x minus 3 plus 2 equals 4 over 4, 3. Then I'm going to add or subtract. So subtract 2 on each side. 11 to the 4x minus 3 equals 3 minus 2, which is 1. Anytime you have 1 on one side and then a base on the other. So this only works if you have 1 on one side. So if there is a 1, you change it to whatever your base is to the 0 power. So I can change this. I have 11, 4x minus 3. I can change this base to be 11 to the 0 power. And that would end up getting me 1. So I can just make, this is a really easy fix because I can just make my base whatever to match the left side, but I raise it to the 0 power. So then I set my exponents equal to each other, and I have 4x minus 3 equals 0. 4x equals 3. So x equals 3/4. And then I am done.